Hello, my name is Brian Reel, and today we're going to be talking about program structure. There are three distinct parts to our NC program. Two channels of programming, which are $1 and $2, plus our MC data or machining data. I would recommend that you determine the process and order of operation before writing machining data. The machining data will be determined by which direction the part is run out of the main spindle. When we write our machining data, we are determining where the back face of the part is located. We are also determining tooling data in our preparation page as to what tool blocks and holders are going to be bolted onto the machine. Based on the information given in MC data, the machine sets up the tool pattern for the appropriate tool holders that we listed in MC data. There are many factors that determine which way the part is processed. Most of the time, the determining factor is which diameter on the part is best to clamp on with the back spindle collet. When determining our machining process, our goal is to split up our main and back spindle time as equally as possible without compromising any features or tolerance required by the part drawing. This could include feature measurements, tolerances, or geometric requirements such as concentricity or perpendicularity. Other considerations include whether special collets or tooling is needed, as well as the need for high-pressure coolant to control chips. We must follow the rules of Swiss-style machining when planning our process. ID work is done first on the main spindle. We also need to process the part in a manner that always allows for plenty of bar stock to contact the land of the guide bushing. A standard TD25NS guide bushing has roughly 3/4 of an inch of land, plus there is an additional 3 mm distance from theoretical Z0 to the face of the guide bushing. For this reason, we never want to pull the material back into the guide bushing more than 3/4 of an inch. For this reason, most parts with multiple features need to be made in segments to allow for proper guide bushing support. However, Swiss-style sliding headstock machines are designed to take cuts up to 300 thousandths per side and still maintain a 32 finish. The part shown here was made from 7/8 stainless steel. The long, slender diameter is 3/16 in diameter and was cut in one pass with the use of high-pressure coolant. Today I'd like to talk about program structure. The L-series machines have two channels of programming. Channel 1 is labeled $1. Channel 2 is labeled $2. $1 is primarily used to do all the machining on the main spindle. $2 is primarily used to do all the machining on the back spindle. The last operation programmed in program channel 1 will be cut off, and the last operation programmed in program channel 2 will be pickoff. The program is set up to simultaneously machine on both spindles at the same time. This will allow for the shortest cycle time possible. Of course, this means that when the very first part is run, the back spindle will not have a part in it to machine. This is normal. No special considerations need to be implemented. The back spindle program will be a subroutine contained within the main body of program $2. Cincom machines have a feature called last part programming. Last part programming is going to be in both $1 and $2 and is contained between program lines numbers starting with G999 to N999. How last part programming works is you have a key called last part on the same screen that you will be auto running the program from. When this key is pressed, it will read the information between lines G999 and N999. If the key is not pressed, it will skip over this portion of the program. Last part programming is designed to manufacture a complete part in one part cycle. Programming the back spindle as a subroutine allows us to call up the back work a second time in $2 after the part is picked off. The back spindle subroutine is executed by calling a line number in $2. In this case, our back work is executed in G630 mode. $1 needs to be in G630 mode as well before the program can continue. M98H100 means search for line number 100. Line number 100 is the beginning of our back work. All of the back spindle operations will be contained within the subroutine, including part ejection. At the end of the subroutine, there will be a M99. M99 tells the program to loop back to the line below the M98H100. So we'll loop back to this line. The next operation in $2 will be pickoff. It is necessary to place a wait command before going into G650 pickoff mode if you are going to control the back spindle rotation from $1. We have a wait command in both $1 and $2 before we go into spindle synchronization. This allows $1 and $2 to sync up before we go into spindle synchronization to allow us to control both spindles from one program channel. M3S1 equals 750, M24S2 equals 750. This is starting up both spindles at 750 RPM. The next line of information, G114.1 H1 D-2R0, is the actual control of spindle synchronization. It says synchronize spindle 2 to spindle 1, spindle 1 forward rotation, spindle 2 reverse rotation, and phase at the C0 point. M77 is simply a command that says wait for the spindle synchronization to complete before moving on. Whenever we cut off and pick off a part, we always push our material all the way out before going into G650 mode. G650 superimposes Z2 onto Z1, meaning that anything Z1 does, Z2 will follow. So we push our material out all the way on this line before we go into 650 mode. once we go into 650 mode, Z2 can be operated independently in $2, but is superimposed onto Z1. We then go into our G650 pickoff mode. The back spindle opens the collet, moves forward, moves over top of the part, and clamps the back spindle onto the part. And then we have another wait command. What this wait command signifies is that the main spindle doesn't cut the part off before the back spindle has grabbed the part. After the back spindle has grabbed the part, $1 will continue to run, cut off the part, and cancel the G650 machining mode with G600 in $1 and in $2. At this moment, after G650 is canceled, superimpose axis is turned off. G600 also makes the back spindle retreat to Z0, meaning the back spindle will go all the way back. As we continue down through the program, we're going to go into last part. If last part is selected on our operator screen, it will run the back work a second time. Otherwise, it will skip over this information. G999 and N999 and $1. G999 and N999 and $2. It will read this information if the last part key is pressed, otherwise it skips over it. The very end of the program in $2, M2 M99 in $1, M2 M99 and $2. At that point, the program rewinds and goes back to the beginning again. After the part has been cut off and pick off, we cancel G650 mode with G600 in both $1 and $2. G600 mode is a mode cancel. It cancels superimposition between Z1 and Z2. It also will force Z2 to move all the way back to its retract position. The next thing that we have available to us is last part program. Last part program is going to be both in $1 and $2. It's going to be contained within G999 and N999. Like I mentioned earlier, if our last part key is pressed on our operator screen in auto or program check, it's going to read the information between G999 and N999. If the key is not pressed, it's going to skip over this information. The very end of both programs is going to end with M2 and M99. These commands also need to be synced together. If $1 would get to the M2 before $1 gets to the M2, it would sit there and wait until they're both on the same M2 line before rewinding to the beginning.